Hello students, good evening all. So welcome to our next session. So this is our third session of chapter applications of integrals. So far we have finished. So basically we are into the integrals part where we have finished with our indefinite integrals and then we have done with our definite integrals and now we are doing our applications of integrals. So in our first and second session, we just had a quick introduction and how we actually do this applications of integrals, like how we actually find the area. So those things we have covered. So today we are just moving ahead with our next concepts in our applications of integrals. So let's quickly have a overview of what and all concepts that in detail in particular we are going to discuss in our today's session. Right, so in our previous session guys, we have already discussed about the symmetrical area, like how we actually find. So basically symmetrical is nothing but we can actually find one part of it and we can one part area we can find it and we can multiply it to how many number of similar symmetrical parts we have. We can multiply those number of times, right? So this symmetrical idea will actually reduce our time while calculating the area of our required portion or required area. Right, so after this symmetrical area, we have even discussed with the positive and negative areas. Right, so you guys even mentioned what is the basic difference here of positive and negative integrals. So above the x-axis and below the x-axis. So we have seen what is this positive and negative areas and we have done questions in respective to this with respect to this concept of positive and negative areas. So coming to our today's session guys, so far what we have done actually, we have taken a particular curve and we have tried to find the area of that curve with respect to the x-axis or else area which is between that curve as well as the y-axis. Right, so these are the things so far we have done. Right, but now we are getting into finding the area when we have two curves. Right, that is finding the area between any two curves. So instead of the previous thing with respect to x-axis and y-axis, here we are going to find the area between any given two curves which are mentioned in the question. Right, so after that we are going to see area between two curves intersecting at one point. Right, so similar to that, so how we'll be finding the area between two curves? So it's actually part of our area between two curves. So in this concept of area between two curves will be involving and engaged with 2-3 corresponding concepts. So that we are going to deal in today's session also. And after that, we are going to see the typical sketches of standard curves. So you might have wondered why we actually have to learn this typical sketch of standard curves. So basically in this applications of integrals, what we guys are actually doing, for any given curve, we are trying to plot the graph of the curve, which is nothing but the sketch of the curve. We are trying to do it. So once we get the sketch, using that sketch, we will be figuring out what are the limits which we have to take and what will be the upper curve and what will be the lower curve. So everything in detail we will be having an idea. Right. So now the question is how we actually drawing or sketching the typical given curve. So we'll be taking some x value and substituting in it and it will be giving the corresponding y value. So using those coordinates x and y, we are actually plotting the graph. Right. So if we could able to know this sketch of standard curves, right, so there is no need to do this substituting of some x value and the corresponding y and getting the coordinates of the point. So these and all not required, right? So by looking at the curve itself, we can identify, okay, this will be the standard curve. So this will be the shape of this curve. This will be the thing and we can actually directly plot the graph. We can directly sketch it. Right, so that's to make it actually even easier, like to reduce our time, to minimize and to consume our time, we can actually go with the sketch of standard curves. Right, so these are the concepts we are going to cover, and along with that, we are going to do some questions. So some are from previous year's papers, JE. So some are from basic level. So we are just going level by level. So basic questions we'll do as well as the difficulty level which are related to our JEE point of view. So those and all we are going to do in our today's session. So let's start with the first one, guys. So the first one is area between two curves. So in that, area enclosed between two curves. So as I mentioned, so instead of having one curve and we are finding the area with respect to x-axis and y-axis, here we will be having two different curves. And our aim is to find the area enclosed between these typical two curves which are given. So let's see here. If there is a function y which is given by f1x and there is a function y, second function which is f2 of x, right? So these are the two curves, right? So here they have mentioned that f of 1x is greater than f of 2x. Okay, fine. So which intersect at 2 points. So these two curves are going to be intersecting at 2 points where the x coordinate will be a and the another x coordinate of the point will be b. Right, so if x coordinate is given, you can substitute in the given curve and you can get the corresponding y value for each of these points. Yes or no? Right. So here you can see the graph. So if for suppose this is my first curve which is f1x and this is my second curve which is f2x, and this is where my point A, where my x coordinate is equal to a, and this is where my point B, where my x coordinate is equal to b. So if you observe, these two curves are actually intersecting at these 2 points, A and B. So now what is the area enclosed between these two curves? So this entire shaded portion is nothing but the area enclosed between or enclosed by these two given curves f1x and f2x. So now how we will be finding? So in general, by looking at these 2 points only, you will be identifying, okay, the limits will be from x equal to a to x equal to b. So that point you will be sure like what are the limits. But the thing is, in our previous things, how we have done? It is with respect to the x-axis or y-axis. So we will be remained with only one curve. So we will be taking that corresponding equation of the curve. But in this entire interval, we are actually having these two curves. So now how we will be finding? So the common area here is given by the upper curve. So whatever the curve, the upper curve minus the lower curve. Right. So that will be our function here. So by looking at the graph itself, you have the initial point which we have predicted is the limits, that is from x will be varying from x equal to a to x equal to b. In our initial cases, for suppose if this is our axis and we are having a line like this, right, and this is x0 and this is xb, right. So if I asked area enclosed between this 2 points with respect to x-axis, in the sense this will be the area it will be coming, right. So then how we'll be taking? So this is the only curve. So what we'll do? We'll directly take the curve. But here we are having to, so the function will be whatever the upper curve. So here the upper curve is y1. So upper curve minus lower curve dx. Because here what are the limits which we have taken? The limits are the x coordinates here. So the area, the common area which is enclosed between the given two curves is nothing but integration to the limits a to b and the upper curve minus lower curve dx. Right, so what is the upper curve, guys? Here upper curve is given to be f1x and lower curve is given to be f2x. So f1x minus f2 of x dx. And in the questions, whatever the functions will be, it will be mentioned and we will be trying to find the corresponding area by doing our definite integration. Right. So if we have to find area enclosed between any two curves in this context, first thing we have to do is we have to plot the curve. So plot the two of the curves. Right. So that will be the first thing. And we have to find the intersection points. So what we have to find? We have to find the intersection points so that we can get our limits. So once we get intersection points, we can identify what is the upper curve and what is the lower curve, which leads us to get the function to get our common area, which is enclosed between these two curves. So these are the three steps which will be involved here in order to find the area enclosed between any given two curves. Right. So as we had a discussion in this, so let's understand this particular concept in detail while solving a question. So here comes the question, guys. So what is the question? Find the area between two curves. One is y square is equal to 4ax and the other curve is x square is equal to 4ay. So here we are given with two curves. So both are nothing but parabola. So y square equal to 4ax and x square equal to 4ay. So what is the first step? As I mentioned, we have to plot the graph or else sketch the figure of these two given curves. So quickly do that, guys, and let me know. I'm just I'll just checking your comment section so that if somebody gives me the answer, I could reply you. So quickly plot the graph first. If we do the sketching of the given curves, we'll be getting an idea what will be the required area, and with that we'll be getting what are the corresponding limits which will be required. So there is nothing to worry here because we already know by looking at the curves, these are nothing but the parabola. So we already have an idea of this standard parabola, right? So y square equal to 4ax will be something like this, and x square equal to 4ay, the sketch of that will be looking like this. So if we observe, the area enclosed between these two curves is nothing but this is the portion of area, right? Which means what is this intersection point? It is nothing but origin, and we have to get the another intersection point which is nothing but here. So how will we getting the intersection point of these two curves? By simply solving this. So how will be solving? So here it is given y square equal to 4ax and the other curve is x square equal to 4ay. That means here we can do, so where we can substitute this here. So it will be y cube and it will be 4 cube and it will be a cube. Right, so 16 into 4, 64. So that can be represented as 4 cube and a square into a cube. So here we are having y cube is equal to 4 cube and a cube. So y will be equal to 4a. Right, so y here is 4a. So correspondingly we can get the x also. So 4a whole square will be equal to 4ax. I am substituting in this equation of parabola. So 1 4a and 1 4a will get cancelled and it will be giving my x also equal to 4a. So now I end up having my intersection point which is given to be x 4a as well as y also 4a. Right. So now if you remember, what are the steps involved here to get the area between two curves? So first thing, plotting the graph, we have done that. Second thing, finding the intersection points, we have done that. And the third thing here, we have to identify what is the upper curve. So this is the upper curve in this required area, which is nothing but y square is equal to 4ax is our f1x. So our function f1x is nothing but root over 4ax. Similarly, what about our f2x? So f2x is nothing but, so in terms of x we have to write, so this is given to be x square by 4a. So now our upper curve is nothing but f1x, so it will be integration of limits 0 to 4a f1x minus f2x dx. And we already know what are the f1x function and what is f2x function. So quickly substitute it and do the integration. That is our definite integration part here. So let me check if anyone has given the answer already. Not yet. Okay. So far I have explained you step by step. First thing, sketching the plot. Second thing, finding the intersection point, and then which ends up giving our leads us to the limits. And the third thing, identifying the upper and lower curve, which will be giving our function to do the integration part. Right, so this is our entire thing. So now what we have to do, our required area is nothing but equal to integration from limits 0 to 4a. So f1x is nothing but root over 4ax minus x square f2x, so x square by 4a dx. So this is the part which we have to integrate it and get the required area here. So quickly solve this definite integration and let me know the answer, guys. Quickly. Simple simplification here. That's all required. Come on, guys, quickly. Did anyone give me any answer? Not yet. So while doing this definite integration, what we can do, we can pull out the constant first. So let me do that. So 0 to 4a here. So root 4 is 2. I can pull that out. And root a is also constant. I can pull that out. So a power 1 by 2 I'm just writing. And I'm remaining with x power 1 by 2 here. Similarly, minus integration of 1 by 4a, as it's a constant, I'm pulling that out, and x square dx. So here also limits 0 to 4a. Right, so we can split this and we can do the integration easily. So quickly, at least let me, okay, Shivaranjani given the answer, good. So what about others, guys? Perfect. So let's see for 2 more answers quickly. I have given everything we have done. We have almost solved the question. So the final step is the simple simplification only required here. So as this is the first thing, I just explained one by one, step by step. So for the next question, I'll just give you time so that you can work it on by yourself. And you'll be, if you are having any doubts, you can let me know, because when you're working on yourself, then only you'll be getting an idea how to do and step by step. And while doing that, if you face any difficulty, you can let me know. I can just clear that out. Okay, Siddharth has given some answer. Can you check once? So let's see. So here we are having 2 a power 1 by 2, right? So that is 2 root a. So x power 1 by 2, that will be 2 root a here. X power 1 by 2 will be x power 3 by 2 here. Right, and in the denominator it will be 3 by 2. So which will be turn out to be 2 by 3 here. And minus, so here it will be, 0 to 4a. And minus here 1 by 4a. This will be x cube by 3. Same thing, 0 to 4a here. Right, so here it will be 4 by 3, a power 1 by 2, x power 3 by 2, 4a to 0. Minus here it will be x cube by 12a. So far that will be our simplification. So 4 by 3, a power 1 by 2. So now let's substitute our limits, that is 4a, because even if we substitute 0, it will become 0. So let's substitute 4a first. So 4 by 3, a power 1 by 2. So 4a, so 4 power 3 by 2 and a power 3 by 2 here. So if I substitute 0, entirely it will become 0. So minus 4 cube and a cube by 12. A here 0, it will be entirely 0. So 4 can be written as 2 square and 2 will be getting cancelled, which will be 2 cube. So 4 by 3. So what is 1 by 2 plus 3 by 2 guys? So it will be 4 by 2, which is a square. So 4 by 3 a square, and this will be 2 square. So 2 will be guessing 2 cube, that is 8 here. Minus here 1a can get cancelled, which will be remaining with a square here, and it is 4, so 4 can get cancelled with 3, so 16 by 3 here, right? So now we are having 8 4s are 32 a square by 3 minus 16 a square by 3, which is equal to 16 a square by 3. So this will be our final answer, that is area bounded between these two given curves, which is y square equal to 4ax and x square equal to 4ay. So what is our required area guys? So the required area here will be equal to 16a square by 3. So some of you might not get, some of you haven't given the proper answer. So you can just check the simplification. There might be an error. So I hope you guys got this point of how to find the angle, how to find the area enclosed between any two given curves. Any doubts in this entire procedure of finding the area required? So if anyone has any doubts, you can quickly let me know guys. If not, we can move ahead with our next. Quickly. Any doubts in this one guys? Or else you are just perfectly clear with it? Okay, got it. So let's move on to the next. So here comes the next one guys. So area enclosed by two curves intersecting at one point and the x-axis. Right. So here initially what we have found out, area enclosed between only two curves. But here area enclosed between two curves where they are actually intersecting at one point. So along with these two curves, and we are going to see the area enclosed with respect to the x-axis also. Right, so let us consider as usual two curves, that is y equal to f1x, that let it be y1, y2 equal to f2x. So these are the curves. So these two are not intersecting at 2 points like the initial one. So in the first one, those two curves are intersecting at 2 points, whereas these two curves are intersecting at one single point P here. So here you can see, let it be a alpha and beta. So let it be alpha and beta, so that we won't be getting confused. Right. So this is our first curve y1, that is f1x, and this is the second curve y2, that is f2x. So these two curves are intersecting at one single point P with the coordinates alpha comma beta. Right. So we have to find the area enclosed between these two curves and the x-axis. So these two curves area between enclosed is this, and with respect to the x-axis, in the sense this entire thing. Yes or no? So this entire thing, it seems, so this will be one curve and this will be another curve, which means what are the limits for this first curve? So limits are from a to alpha. So we can write it like this. So from a to alpha, we are having the first curve enclosed. So what is our first curve? That is f1x dx. And plus after that, that is from alpha to B, we are having the second curve here, that is f2x dx. So this will be our required area. right? So by comparing to the previous one, this one will be a quite easier than the previous one, because there is no, like, we won't be getting confused which will be the upper curve, which will be the lower curve, which we have to subtract, add, and those and all things will not be getting here, because it's simply as simple as that these two are curves which are intersecting at one single point P with coordinates alpha comma beta, right? And the area enclosed between these two curves and the x-axis has to be found out. That will be our required area. So this will be the required area, which is given by integration within the limits a to alpha for the function f of x dx, plus integration within the limits alpha to beta for the function f to x dx, because here this is our first curve which is varying from the point 0 to point A to alpha, and this is our second curve which is varying from the point alpha to point B, that is our x coordinate, right? So I hope you guys are clear with this second part of our thing, which is area enclosed by two curves which are intersecting at only one single point and the x-axis. So let's see the third plot here. So here comes the third plot, guys. So that is area bounded by two intersecting curves and lines parallel to the y-axis. So here we are having two intersecting curves. So let's consider two curves, again the same thing. One is y equal to f of x and the other function is, other curve is g of x. Right. So in this figure, if you plot the graphs of these two curves, they are looking something like this. Right. So now we have to find the area bounded by these two intersecting curves and the lines parallel to y-axis. So these two intersecting curves, so this will be the required portion of area. Right. Why? Because this will be my function f of x. So it will be something like this. And this will be my function g of x, which is something like this. And with respect to the lines parallel to y-axis. So the lines which are given here parallel to y-axis is x equal to a, x equal to b, and x equal to c. So another y-axis points are given, that is x equal to a, x equal to b, and x equal to c. So a less than, c less than b. Right. So this is the order. So now if we drop those lines, we end up having the required portion of area, which is this shaded portion. So now if you observe, so for the first part, our f of x is the upper curve, whereas in the second part of the figure, g of x is the upper curve. So how we will be doing the required area portion? So area will be given as, so first x point, so from first x to x equal to a to c, that is from a to c, what is the upper curve here? F of x. That means here the area will be f of x minus g of x dx. So this is the area which is given by this small shaded portion here, right? So we are having this another portion, so plus, so now the limits are varying from x equal to c to x equal to b. So in this figure, if you observe, what is our upper curve? So here our upper curve is given by the function g of x. So now it will be g of x minus f of x and the whole integration to dx. Right. So when we are having, so initially with respect area bounded by the curves as well as the x-axis we have seen. So now what we have seen, area bounded by the two intersecting curves and the lines parallel to the y-axis. So that also we have seen here. Right. So this is how we'll be writing. So while doing these kinds of things, we have to show like what is our upper curve and what is the lower curve. Right. So let's just do a question here, guys. So here there is a question. So quickly read it and give it a try. Because now you might have got familiar with how we are doing these things. So using the method of integration, find the area of the region bounded by these lines. So whenever we are having these kinds of lines and stuff, the first thing anyways will be the plotting the sketch. So do that, guys, quickly. So the only thing we can do here is, first thing we just have to plot our graph of these three given lines. Then only we could get what is our required area, so that we could get our limits. So quickly plot the graph, guys. If anyone did plotted already, you can let me know. See what are the given lines here. 2x plus y is equal to 4. Second one, 3x minus 2y is equal to 6. And the third one, x minus 3y plus 5 is equal to 0. So take your time, guys. Quickly let me know if any one of you has already plotted the graph of this. So we'll be plotting. So this is linear equation in two variables, guys. So from your 9th and 10th standard, you guys are aware with how to plot a linear equation in two variables. How can we plot the graph of it? So take some x. So this is our first line, second one and third one. So take some x value and corresponding y you have to find out. So in general, let's substitute x0. So if x is 0, y will be 4 here. Similarly, substitute y0, then x will be 2 here. Right. So let's substitute x equal to 1. So if x is 1, y will be 2. Right. So 3 points will be enough for to plot a linear equation in two variables, to plot the graph of it. So x0 and y4, let us take somewhere here, and x2 somewhere here, and y0. So let the point be here. And the next one, x1 and y2. So it will be somewhere here. So the line will be like this. So the graph of our first line, that is 2x plus y is equal to 4, will be like this. So I'm just naming it to be first curve, so that I can write it here 1. So what about second one? So same funda here. Substitute x0. Then what will be the y here? So if we substitute x0, y will be 2. So minus 3. So let's take y0. So if I take y0, it will be 2. Right. So 3, it will be 2. So this will be this will be 0, right? So it will be minus 3. Then let's take x1. If I take x1, so 6 minus 3 will be 3. So it will be some fraction, 3 by minus 2. Okay, 2 points will be enough. So x is 0 and y will be minus 3. So somewhere here we can take. And x is 2 and y is 0. So this is again the intersection point, we can say. So this line will be going something like this. So this is our plot of equation 2. So this is the intersection point, you can say, that is x2 and y0. So let's move on to the next, that is x minus 3y plus 5 equal to 0. So let's substitute y, okay, x here and y. So let's substitute y0. If I substitute y0, x will be minus 5. So let me take x1. So if I take x1, sorry, let me take y1. So if I take y1, then it will be 5 minus 3, 2. It will be minus 2. Right, so let's take y equal to 2. Then it will be 6. So minus 6, so minus 1, it will become 1. So we'll be having x1 and y will be 2. So somewhere here, because 1 and 2 is also common for our first line. So this will be the thing, this will be the point where 1 comma 2, because that is the common point for our equation 1 and equation 3. And then what else we are having? X minus 5. So somewhere here, x minus 2, sorry, and y1. So somewhere here. So the plot will be looking like this, I think. It will be going like this. Exactly. So what is the area enclosed between these three lines? So this is my line 3. So this is my area enclosed by these three lines. And what are the intersection points? You can see 1 comma 2, 2 comma 0. And there is intersection point for our equation 2 and 3 also. Let's take x4 and see. If x is 4, 4 minus 3y plus 5 equal to 0. So 9 by 3 equal to 3. That means 4 comma 3. So this is our intersection point of 2 and 3 lines, which is 4 comma 3. So now we have drawn the sketch of these three given lines, and we got the required area of the region, and we have even find out the corresponding. Okay, Siddharth already given the area, guys. Okay, so what about others? Okay, so now we have just got the plot and the corresponding intersection points also here. So now what will be the thing which we have to do? Simply writing our integration. That is our required area. So I'll just erase this part of it. So quickly write the integration part, guys. Right. So here if you observe, whenever we are having area enclosed between curves, first thing we have to check what is the upper curve. So here this line 3 is the upper curve, obviously. And the remaining two are lower curves, which means what we have to do? Upper curve minus lower curve. Right. So as simple as that. Right. So here what is our required area now? So upper curve minus lower curve. So here our upper curve is nothing but equation 3. So we have to write in terms of x, as we are going to take the x coordinates. So what are the x coordinates here we are having? It is varying from 1 to 4. So 1 to 4. Equation of this in terms of x will be x plus 5 divided by 3 dx. So this is our upper curve. So the next remaining two lines are nothing but lower. So we have to minus. So minus. So for let me take this line 1. from where it is varying from x1 to 2. And in terms of x, line 1 it is given to be 2x minus 4 minus 2x. 4 minus 2x dx within the limits 1 and 2. So now again the other curve should also be subtracted because that is also a lower line. So let's see the next one, that is this one. It is varying from x2 to 4. So the limits are from x2 to 4 here, and this is our line 2. So in terms of x, this should be 3x minus 6 divided by 2 dx. So by simplifying this entire integration, you will be end up getting the required area of the given line. So area enclosed by area bounded by the given 3 lines here. Right. So far if you have any doubts, you can let me know, guys. Because if you guys can get into this step, the next one will be the simply substitution and simplification that we'll be doing. So I think so far no doubt. So let me do the next simplification part here. So what is our required area, guys? So first one, within the limits 1 to 4, x plus 5 by 3 dx. And the second one, minus from 1 to 2, 4 minus 2x dx. Minus from 2 to 4, 3x minus 6 by 2 dx. So let's separate them first so that it will make easier. So here I can separate this as x by 3 and 5 by 3. Right. So for x by 3 it will be x square by 2. So which will be x square by 6. So here it will be 1 to 4. Plus here it will be 5 by 3. So it will be 5 by 3x. 1 to 4. Minus 4x within the limits 1 to 2. So minus into minus it will become plus. So 2 it will be 2 into x square by 2. 2 will be getting cancelled. So we'll remain with x square 1 to 2. Again minus 3 by 2 will be there, and will be integration of x will be x square by 2. Limits 2 to 4. So minus into minus plus, that is 6 by 2 will be 3, that is 3x. Limits 2 to 4. So we have to simplify this entire thing in order to get our area of the given region. So if I substitute 4, it will be 16 by 6 minus 1 by 6. Next thing, plus 5 into 4, that is 20 by 3 minus 5 by 3. And here minus 4 into 2, 8 minus 4. Plus here 4 minus 1. And here minus. So in the denominator it is 4. So 1, 4 will already get cancelled. So it will be 12 minus. So 2 square. So 2 square will be 4. So both will be getting cancelled. So minus 3. And then plus 3 into 4, that will be 12. So 12 minus 6. So you have to simply find the answer here. So it will be 15 by 6, then 15 by 3, then 4, then 3, then 9, then 6. So here 9, 13. So minus 13, here minus 10. So minus 10 plus 4 will be, plus 6 will be minus 4. So 15 by 6 plus 15 by 3 minus 4. LCM will be 6. So 15 plus 30 minus 24. Right. So what will be the final answer here? That is 15 plus 30 minus 24. That is 21 by 6. So in 3 it will be getting cancelled. 3 7s are 21 and 3 2s are 6. Right. So what is the final area of our required region which is bounded by the given 3 lines here? That is given to be 7 by 2 square units, or else we can write it as 3.5 square units. Okay. I think most of you has got it. Okay, no issues. So this is how we'll be doing. So from next onwards, this simplification I won't be doing. You have to do it by your own. So because you already done with the indefinite integration, you have already done with the definite integration. So that's not a big issue. So you can do it by your own. So let's move on to the next question. So here comes the next question, guys. So read the question and try and get the answer for it. Find the area of the required region. So I think it is a previous it's a JE question, previous years. Some year they have given in JE mains level. So read the question carefully, guys, and draw the sketch and find out the intersection points which will give you the limits, and then draw the and then get the area required. So I think we have done the similar question. So hope you guys can do it by your own and let me know the answer. So let me check if anyone of you got the answer. Okay, Shivaranjani has already given the answer, guys. 16 by 3. Siddharth also given. Okay. So if you remember, just now we have previously solved our similar parabolas, which is given to be y square equal to 4ax and x square equal to 4ay. So for these curves, area bounded by these two, what is the area which we got? 16a square by 3. So by comparing these two standard curves and the given curves, what is the a value? So I am just explaining you the shortcut. So the procedure will be the same thing how we have done just now. So you can follow up with that. I'm just by comparing it, I'm just giving you the thing. So here a will be 2, 2. So we can directly substitute that. So our required area will be 16 into a square, that is 2 into 2 by 3. So 16 into 4 will be 64 by 3 square units. So this will be the answer, that is the area bounded by these two given parabolas. Right, so let's move on to the next one. So here comes the next question, guys. So this is the area which is related to the inequalities of the equation. So the curves which they have given here, the inequalities which they have given, y square less than equal to 4x and 4x square plus 4y square less than equal to 9. I hope you can do this one because we have done similar questions and you know how to do a plotting of us drawing the sketch of any inequality, because that we have discussed already. So in the linear inequalities chapter, you might have come across this graphical solution part and all. So there you have learned how to do this solution of according to the inequalities, how to do the plotting of the curve. So you have to apply that here. So plot the curves first. So the first one will be a parabola y square equal to 4x. You can plot that first. You can draw the sketch of it. And the next one here, it's a equation of a circle. That's the inequality of the circle. So first try and draw the sketches of this parabola as well as the circle. And try to find the intersection points. And then you can get the shaded or the required region of our area. Okay, Siddharth has already given the answer. So let's see if anyone are getting the same answer so that you can match it. So without this inequalities, you can first consider them as y square equal to 4x, and so here I am just simplifying it. X square plus y square is equal to 9 by 4 can be written as 3 by 2 whole square. Right, so you can consider the given two curves as in this format as the equal to without the inequality. So then we can plot the graph, we can get the sketch easily. So there is nothing new, like there is no need to take this random x value and substitute and all, because by looking at the given curves itself, you might already have an idea like, okay, this and the corresponding shape will be this, and this is the circle with the center 3 by 2 and with with the center 0 comma 0 and with radius 3 by 2. So you know how to get this one also. So let me just do the sketching part. So this is the center of the circle will be origin and the radius will be 3 by 2. So let me draw the circle first. And this is our parabola y square less than equal to 4x. So equal to, right? So here they have mentioned y square less than equal to, which means less than curve will be this entire thing for parabola, and even for the circle it is to be less than, which means inside the circle. So this is the only portion which includes both the parabola and the circle, which is less than equal to. So that means this is our required portion of area. So this intersection point is 0, 0, and this intersection point x coordinate will be 1 by 2. So we can get this from here. So 4x equal to 9 by 2. So by simplifying this, you can end up getting x equal to 1 by 2. So no need to worry of y, no need to find it. So we can get it also by substituting here. So y will be, so y square equal to 4, 1 by 2. So y square equal to 2 means y means somewhere around root 2. So but we are dealing with only one x coordinate. So this will be 1 by 2. So now you got the idea, like this is our region and the corresponding x coordinates here. Right. So I think some of you has given the answer also. No issue. So now what you can do, I'll just show you the integral part so that you can simplify it by your own and get the final required portion of area. So here guys we are, so our required area will be equal to, so if you observe it is parabola and circle, so these two parts are symmetrical area or not. So we can take it as 1. So I am taking twice of this because I am just trying to find out one part. So this is part 1 and this is part 2, and these two parts of area are symmetrical to each other. So 2 times of integration. So from this point to I will be going until this point. So here I am having 1x because this curve is my parabola curve, whereas this curve is my circle curve. Right. So I am going to cut it here. So from 0 to 1 by 2, I am going to have my parabola curve. So what is my parabola curve in terms of x? So y square equal to 4x, that can be written as root over 4x dx. Plus, so this will be the entire 2 times, right? So plus I will be going to have integration again from 1 by 2 to the next part will be until this point where my x coordinate is 3 by 2. So here what is my curve? That is my circle. I have to write in terms of x. So it will be y minus 4x square by 4 under root. So this will be my curve guys, that is 9 minus 4x square by 4 dx. Right, so you have to just apply your definite integration now and you have to simplify this in order to get the area of the required portion for this given two curves, which are nothing but inequalities also here. Right, so as I have given, so here you can observe I have just written this 2 times, which means this entire portion is area of my part 1. As I have to find the entire area, that will be my twice, as these two portions are symmetrical. So it will be twice. Right. So you can do the further integration, definite integration. So you guys know how to do this definite integration and all. Right. So you can check it. If you have any doubts while simplification, again you can let me know, because we have already done with our definite integration. So there is no need to worry. You can do it by yourself. So I think that's all for today guys. So we have covered mostly like the concept of area with respect to two curves, like under the like between the curve, with respect to the curves and the x-axis, with respect to the curves and the y-axis. So these are the typical topics which I have covered today. So we are reminded with the standard parts area and all, so that we are going to cover in our next session of our applications of integrals, which is nothing but area under the curve. So that's all for today guys. So please try and solve this integration part, definite integration part, and let me know if you still have any questions while solving this. So thank you guys. So that's all for our today's session. Thank you.